Hi students, in your mathematics textbook there are 11 chapters in total. See the chapters. In these 11 chapters, some chapters are very lengthy and important in the examination point of view. Such a chapter is your second chapter, circles. Today we are discussing the first part of the chapter, circles. Are you ready? Okay. Before starting our chapter, we have to recall some points that we studied in lower classes. What do you mean by right angled triangle? Right angled triangle. We know if the measure of one angle is 90 degree, then that triangle is called right angled triangle. If in a triangle measure of one angle is 90 degree, then it is called right angled triangle. That we already studied. See, in this triangle ABC is right angle. Angle B equal to 90 degree. Then what about the remaining angles A and C? Since the total sum is equal to 180 degrees, the sum of angles A and C become 90 degree. So it's an important point. In a right angled triangle, one angle equal to 90 degrees and the sum of the remaining two smaller angles is equal to 90 degree. Okay. Then using these concepts, we have to draw a right angled triangle, but one condition there, the length of the hypotenuse is equal to 7 centimeters. Only one condition, length of the hypotenuse is 7 centimeters. So if you are first drawing a line of length 7 centimeter, since the hypotenuse is opposite to the right angle, the two angles at the ends of this line should be less than 90 degree. Then we know that in right angle triangle, sum of the smaller angles is equal to 90 degree. So we can take two angles at the ends of this line as 30 degree and 60 degree. See the figure. Here the two angles at the ends of the line are 30 degree and 60 degree. Therefore automatically the third angle become 90. Instead of taking this 30 and 60, we can take so many other pairs. The condition is the sum of that two angles equal to 90 degree. Instead 30 and 60, I am taking another pair. You see the figure, 20 degree and 70 degree. 20 plus 70 become 90. Therefore, the third angle become 90. So, we can take many pair of angles. The condition, sum of these angles equal to 90 degree. Just take a line, then first an angle at the first end, 1 degree angle at the second end, 89 degrees. Then 2 degrees and 88 degrees. 3 degrees, 87 degrees. If you are taking this type of angles at the ends of this line, the figure become like this. In that figure, our first line AB is the diameter of a semicircles. You just listen, that third vertices lie on a semicircle with our first line as diameter. It's a very important point of our chapter. If we join the end points of the diameter of a semicircle to a point on the circle, then we get an angle of measure 90 degree. That is, we get a right angle. It's very important. If we join the end points of the diameter of a semicircle to a point on the circle, then we get a right angle. Okay, then see the next figure. In the next figure also, AB is the diameter. We started two lines from both A and B, but joined to a point. But that point is not a point on the circle. Point is outside the circle. See the figure. Then there forms an angle. That angle is less than 90 degree. It's very clear in the figure. If we join the end points of the diameter to a point outside the circle, then angle formed is less than 90 degree. Then see the third figure. In that figure also the end points of the diameter are joined, but not to a point on the circle, not to a point outside the circle, but we joined the end points of the diameter to a point inside the circle. Okay, we joined end points of the diameter to a point inside the semicircle. Then from this figure it is clear that that angle is obtuse angle. Obtuse angle means its measure is more than 90 degree. Okay, then if we join the end points of the diameter of a semicircle to a point on the circle, then it is equal to 90 degree. To a point outside the circle, then the angle is less than 90. To a point inside the circle, then angle is more than 90. That is the first point of our chapter. Yes, you just see the video. In the first figure, the red triangle, the third vertex moves along the circle, therefore that measure remains same, the measurement equal to 90 degree. But in the second triangle, when the third vertex is inside the semicircle, its measure is more than 90. When it reaches to the point on the circle, then it becomes 90 degree. When it is outside the circle, then it becomes less than 90. Okay, then we can go to our first problem. See the first problem. Just read the problem. In the figure, if we draw circles with its sides as diameters, then what about the point? What about the third vertex? Is it inside, outside, or on the circle? A triangle is given, triangle ABC. If we draw a circle with its sides as diameters, then what about the third vertex of the triangle? Is it on the circle, inside the circle, or outside the circle? It is very clear. It depends on the measure of the angle. Just take the first side AC. If we are drawing a circle with the diameter AC, then we have to check whether the point B is inside, outside, or on the circle. It depends on the angle at the point B. Just to see, the angle measure is 80 degree. 80 degree is less than 90, therefore that point become outside. Okay, if you are drawing a circle with AC as diameter, then the point B is outside the circle. Similarly, angle A equal to 40 degree, angle C equal to 60 degree. All the angles are acute angles, their measures less than 90. Therefore, if we draw circles with the sides of this triangle as diameter, then the third vertices should be outside the circle. That is the answer. Okay, then the next problem, the second problem. See the problem. For each diagonal of the quadrilateral shown, check whether the other two corners are inside on the circle or outside the circle with that diagonal as diameter. It is given a figure ABCD, a quadrilateral ABCD. If we draw circles with diagonals of that quadrilateral as diameters, then what about the remaining two corners, remaining 2 points? Are they inside the circle or on the circle or outside the circle? That is the question. First we can take the diagonal BD. Diagonal BD. If we are drawing a circle with diagonal BD as diameter, then we have to check the points A and C. You see the measurement of angle A and C. Measures are 105 degree and 110 degree. Both are more than 90 degree. Therefore, that 2 points inside the circle. If you draw a circle with the diameter BD, then the points A and C are inside the circle. Reason is measures of A and C are more than 90 degree. Okay, next we have to consider the circle with the diameter AC. Diameter AC. Then check the points B and D. But here in the problem, the measurement of angle D not given, but angle B equal to 55 degrees. Measurement of angle D we can find using the angle sum property of quadrilaterals. We know the total sum of the 4 angles of a quadrilateral equal to 360 degrees. Therefore, the measure of angle D equal to 360 degree minus of 105 degree plus 110 degree plus 55 degrees. Then it become 360 degree minus of 270. 360 degree minus 270 become 90 degree. So, the measure of the angle at the vertex D is equal to 90 degree. Now, we have all the angles. Then take the circle with the diameter as AC. The circle with the diameter as AC. Then D is on the circle. Reason angle D equal to 90 degree. Therefore, D is on the circle. What about the last vertex B? Its measure is 55 degrees. That is less than 90 degree. So, B is outside the circle. I am giving 2 questions for you as homework. Then you have to do the answers and we can discuss the answers and next part of this chapter in the next class. Okay? Goodbye.